right, so we're going to start with number 3 here. Number 3 is also done on A blocks, but we'll do it again. It seems like a lot of people want number 3. And walking around, I think I know the problem that most people had with number 3 because I saw it in your force diagram. So, yeah, because of the number 2 there, if you need the flash on it. Some people, it depends on your phone, whether or not your phone supports flash. So, I would use the computers. You know, you can have multiple windows open. Right? That's how most people would work around it. Yeah. So, you know, you can just have multiple tabs, and each would be in your own. All right. So, slingshot, rubber band, pull back center band with this force, and the angle between the two halves. This was tension in the band. All right. So I'm going to start off number 3. The way I'm going to draw my rubber band, my slingshot, here's the 2 ends of it. Okay. The rubber band is going to be stretched like this. And now one thing you may not realize is that because you have one continuous band, you have the same tension throughout the whole thing. Even if you didn't realize that, you could prove that. But if you do realize it, that's even better. So I apply a force in this direction. I have a force due to tension on the rubber band, 2 of them back in this direction. And they tell me that the angle between this is 110 degrees. So there's my force diagram, the one that you'd be graded on for the diagram part. All right, and then I'd go down to my free body here, which is part of my how, so part of my how grade. And I have FT and FT and F. And I have in here 110 degrees. So I'm going to draw the components over here of FT and FT. Since it's 110 between them, when I draw these horizontal components, I pick half of 110, which is 55 degrees. You can picture those 2 sliding together to form 110. And then you have the ups here and the downs here. Right? Labeling those, this side is going to be FT sine 55 degrees and FT sine 55 degrees. These green sides would each be FT cosine 55 degrees. So there's my free body. But now I'm going to do it in terms of X and Y. I'm not going to worry about the Y direction because notice I have just the 2 components there. And they're going to cancel each other out. Now, it could be, that would be used to prove that the tension was the same on both sides. You know, I could put those 2 into my Y side and end up with that FT equals FT. I already kind of realized that because it's a single band. So I'm going to focus just on my X side. And just on my X side, I'm going to have FT cosine 55 degrees and FT cosine 55 degrees. Back here I'm going to have F. So I'll do the sum of my forces. The X equals MAX. 3 forces, no acceleration. Which way do you guys want to call positive? All right. So negative f plus ft cosine 55 degrees plus ft cosine 55 degrees, ran over my line, equals the inertia times 0. I think they tell me what F is, right? 2.73 newtons. So what I know here is that F equals 2 times Ft cosine 55 degrees, right? Yes? Oh, good. F is 2.73. So if I want to get Ft by itself, I can substitute in here 2.73 newtons over 2 times cosine 55 degrees equals Ft. Solve for Ft. Use my handy dandy calculator. What's that number? 2.73. 2.73 divided by parentheses 2 cosine 55. And I get 2.38. 2.38. See if that's right. A lot of you on your fourth diagrams had a weight in there. We don't know the weight. So I'm going to do number 5 here. Spider on the vocalist on the strand of spider web, calculate the tension. First spider who has mass of this. Okay, so this one you actually need 2 force diagrams for, right? Because the part A is different from part B. So if like you had this one tomorrow on that in-class problem, you'd need to do 2 force diagrams for it. All right? Luckily, the first one is very, very straightforward. So number 5 here. The first one, I think I'm going to see. The first one I'm just going to do really small over here. There's my spider, F sub G, tension. That's all you need for that. For this is part A. I think I'll do part A and then come back and do part B. So part A, that, a free body, of course, for that would look like this. F sub T, F sub G. And then that would only be in the Y direction. You know, I'm going to do it right here. And so I do sum of the forces in the Y equals M-A-Y. You guys are getting this modeling idea that I'm showing you how I expect to see them done, right? Hopefully. When's the first time I'll get to grade you doing these? So I'm just reinforcing. So I have Ft minus Fg equals M times 0. So Ft equals Fg. We know from our equation sheet that F sub G is the mass times the gravitational field strength, mg. So Ft equals m times g. They tell me my mass, 7 times 10 to the negative 5th. So 7 times 10 to the negative 5th kilograms. And my G is 9.80 newtons per kilogram. There you go. Multiply them together to get A. So let's do part B now. Back up to the top. For for part B, now where spider is held up by these two strands, and I don't feel like redrawing this, so let me cheat. Yeah, use my available technology. And we'll shrink that down a little bit so it fits in here. Okay, so we would have, we would have f sub g down. We'd have, now does it say continuous middle linear horizontal standard spider web? Okay, so it's a single strand, so the tension is going to be the same in all of it. Okay, so I'm going to have f sub t this way and f sub t this way. Oh, it's starting to look a lot like the previous one, isn't it? Like the one we just did. So let's see. Now I do my free body. Free body of that part. Do that over here. All right, but then I'm going to do my components. They tell me that this angle is 14 degrees, I think. All right, I think that's what mine says. Some of you guys that are just sitting there with your feet up on the desk, you may want to get some of these done unless you already have them all done. Here's a solution that some other people are doing. They've opened up multiple windows on the computers and are working on them then. Or they're actually writing stuff down. Wow, what a concept. They are wicked smart. We have that nicely on the video now. I hope so. Excellent. That's outstanding, Mr. John. All right. So in here, these are f sub t's. So in here we'd have f sub t sine 14 degrees. And on each of these green ones, we'd have f sub t cosine 14 degrees. All right. Well, let's see what it says. Angle is 14 degrees, and I have the diagram gives me theta on both sides. So it'd be the same, because they're right in the middle. If the spider wasn't in the middle, you'd have different angles, right? Yeah. Still the same, still a common tension, but different angles in there because the spider wasn't in the middle. All right, so now down to my free bodies for x and y. In the y direction, from this I have f sub g and ft sine 14 degrees and ft sine 14 degrees. Here I have ft cosine 14 degrees and ft cosine 14 degrees. I don't think I'm going to bother with the x much because all I'm going to prove is that ft equals ft. I think I'll focus more of my effort on the y side, where I have that the sum of the forces in the y equals m a y, and I have, let's see, I'm guessing you guys want up to be positive. Why do I even ask anymore? I'm hoping one day it'll be a different answer. Oh, wait a minute, I figured out the... I want the tension now. This is so... I'm feeling like deja vu here. What's this like? Didn't we just do this one? So rather than FG, I'm actually going to write in MG, right? And then substitute my values. Yeah. Yeah, you could use that number. Yeah. That's what I was thinking of going that way, actually, rather than doing it again. But what was mine? 7 times 10 to the negative fifth. You should get relatively a very large number, because sine of 14 is going to be a very small number, right? So let's see if we get a relatively large number. Oops. This. So, parentheses, 7 EE negative fifth times 9.8 parentheses divided by parentheses 2 sine 14. Sine 14. Close, enter. That's a relatively large number when we start off with 7 times 10 to the negative fifth. It's above your comma, which is next to your x squared. You find it? The second comma back here. But I can show you. I haven't cleared it in a while. You found it good. Okay. I've hit a few keys there. So let's see if that's right. 0.0142. I'm going to put whatever number this is. Number 6, I think. Hey, look, they already did the force diagram for us. Woo! Don't need to do it. Well, I didn't have to do it because I could just copy it. All right, so now I'm going to do my free body. I'm going to stick with their notation here, okay? Or wait a minute, I'm going to switch this W to F sub G. And this would be FT2 and FT1. Okay? Just changing up their notation to match what we have been doing. So, my free body dot F sub G FT2 FT1 doing my component diagrams. Well, that's a good name for it. They tell me this angle is 10 degrees. This is FT2. Tell me this angle is 15 degrees, right? I think. Yeah. Now, this is a part that if you try to memorize, always use cosine for horizontal and sine for vertical or whatever, it's going to mess you up. Because I've got this angle up here, so this horizontal component is opposite the angle. So the horizontal part here is ft1 sine 15 degrees. 6. Here the 10 is between is at the other end of the triangle. So the horizontal is ft2 cosine 10 degrees because it's adjacent to that angle. Cos is adjacent, sine is opposite. Yep. Always think to see a sine, you've got to be opposite. That's one way to remember it. And then the other one has to be adjacent. And then this side, the vertical side here is going to be ft1 cosine 15 degrees, and the vertical side here is ft2 sine 10 degrees. All right? So, doing my individual free bodies, let's do the horizontal first. Should just put dots in the center. ft2 cosine 10 degrees, ft1 sine 15 degrees. Then over here on my vertical, f sub g down, ft2 sine 10 degrees, ft1 cosine 15 degrees. So the y side is going to tell me how these two forces are related to the weight of the person, and the horizontal forces are going to tell me how the two tensions are related to each other. Can you kind of see that from this? It's not apparent until you look at these individual free bodies. But my guess is that I'm not going to be able to find anything until I find both things and then work them together. So let's start on the vertical side. And let's see, do they tell me the person's 77 kilograms? Okay. There we are. So I'm also remembering that FG is mg. So I start some of the forces in the y equals m-a-y. Same way I start everyone. And I have f t1 cosine 15. I'm assuming you guys want up to be positive. Minus fg equals m times 0. So f t1 cosine 15 degrees plus f t2 sine 10 degrees equals mg. Can't really go any further there. So I'm going to flip to the other side and start with my one equation. And I have negative f t1 sine 15 degrees plus f t2 cosine 10 degrees equals m times 0. ft1 sine 15 degrees equals ft2 cosine 10 degrees. Now I'm kind of stuck on both sides, right? Because I got two unknowns on each side. But luckily, I have the same two unknowns. So I can solve one side, say for T1, and then put it into the other side and only have T2 left in that side. Do you guys want to solve for T1 first or solve for T2 first? Find T1 and then, okay. So what I'm going to do is I'm going to solve the X side here for T2 and then put that in over there to get rid of all my FT2s. So I'm going to have FT1 sine of 15 degrees over cosine of 10 degrees equals FT2. Right, just rearrange it, get FT2 by itself. And then I'm going to substitute that in over here with other things I know and have FT1 cosine 15 degrees plus FT1 times sine of 15 degrees. I'm substituting. Actually, I should probably, let me do this one in green so you can follow it easier. FT1 sine 15 degrees over cosine 10 degrees times sine of 10 degrees equals mg. So I substituted that in. And then rearrange it just for itself. FT1 times cosine of 15 degrees plus sine 15 degrees over cosine 10 degrees times sine 10 degrees equals mg. And bell's about to ring, but you would just, now you've got all numbers that you can deal with because you know M, you know G, and then find a value for FT1, their numerical value, and then put it up over here to find FT2. It's just math now.